the formula of differentiation, like the basic formula for x to the power n, then the related formula for trigonometric functions like sine, cos, tan, etc., and exponential and logarithmic functions. Then the properties of differentiation, including these quotient rule, the product rule, and of course, most importantly, the chain rule. So this is the part of differentiation, like the different techniques of differentiation, including chain rule, which is going to be of major weightage in the coming test on Sunday, right? So from this portion of physics is going to be all about techniques of differentiation, the type you have done up to worksheet number 3, and also 1 or 2 questions based on the application of differentiation, like the area and volume type of questions that we've done from exercise 3, the first 2 or 3 questions, those type of questions. Okay. Anyhow, so let's begin today's session. Okay, so last lecture we were looking at some of the applications of differentiation, including the chain rule kind of application of differentiation related to differentiation as a rate measurer. So if we have some quantity which is varying with time, like let's say the radius of a sphere which is varying with time, then we can understand the rate of change of its volume or the rate of change of its area with respect to time, because area or volume, surface area or volume, whatever, is a function of radius, and radius is varying with time. So radius is a function of time. So by using the chain rule concept, we can find out the rate of change of any other quantity related to the radius, which is changing with time. So those type of questions are called the rate measurement type of questions using differentiation. Or there are direct rate measurement questions like velocity is given as a function of time. So rate of change of velocity is acceleration, or displacement or position are given as a function of time. So rate of change is equal to the instantaneous velocity, and so on and so forth, right? So before we come to the doubts from the worksheet number 4, let us look a little bit ahead. So further looking at applications of differentiation. We understand that differentiation can be used to understand the behavior of a function in a certain interval for the independent variable. Like if we have a function y is equal to fx, then by looking at the value of the derivative, that is the value of dy by dx in a certain interval of x, we can find out the behavior of the function in terms of whether y is increasing with respect to x or y is decreasing with respect to x. Okay, so let's understand this with some examples. Behavior of a function, let's say y is equal to fx from its derivative dy by dx, or that's the same thing as, in short form, what we write as f prime x. Okay, so how do we understand the behavior of a function? So imagine that we have some kind of function whose graph, let's say something like this. So supposing this is the graph of a certain function which has this kind of behavior, that from a to b for x, you can see the value of the function increases, or y increases with x. But then from b to c, it has an opposite kind of behavior, that as we increase x, y decreases till it reaches some kind of dip point at c, and then again y increases with respect to x as we go from c to d, let's say. Okay. So now what you'll notice logically is that when you examine the graph of this function, okay, you can see that if I draw a tangent at any point like this over here. At any point between A and B, if I draw a tangent, it'll be a straight line with a positive slope. Because you can see that that line will be such that it's making an acute angle with respect to the x-axis. So this tan theta will be positive. Similarly, between C and D, if I draw any point, if I draw the tangent at any point, it will have that same kind of behavior, that it will have a positive slope. But on the other hand, if I draw the tangent at any point between B and C, some point like this, if I draw the tangent now, you can see that that tangent will tend to have a negative slope. And this directly correlates with the behavior of the function, because you can see the behavior of the function is such that y increases with respect to x. For first of all, x belonging to the interval a to b, or you can say for x greater than a but less than b. And you can see y decreases with respect to x for x belonging to the interval b to c. Because the graph of the function is such that it's showing you that as we increase y, as we increase x, the value of y is dropping. And then again, y increases with respect to x for x belonging to the final interval c to d. So this is just, for example, suppose the graph of the function is like this, then this is the information we are getting from the graph. But also, you can see that the slope of the tangent, which is nothing but the value of dy by dx. So this slope of the tangent or the value of dy by dx is positive for, again, x belonging to a to b, and again for x belonging for c to d. So these two intervals, you can see, correlate with these two intervals where the function is increasing. And dy by dx, or the value of the dy by dx, is negative for x belonging to the interval b to c, which you can see in the graph. So this interval correlates to this. So this we can now generalize and say that therefore fx, that is the function, will increase in an interval in which f prime x or dy by dx is a positive quantity, and fx will decrease in an interval in which f prime x is equal to a negative quantity. Of course, f prime x can also become 0 at a point, so we'll come to that also. But first of all, we can see that if in an interval the value of the derivative is positive or negative, then from that we can directly correlate that in that given interval the function is either increasing or decreasing. So just make a note of this point over here and make sure you understand the correlation between the graph drawn and the information given about it here. If there's any doubt, just let me know. Shayan, I'll answer your question in a moment. Okay. E is a constant in your question. So we'll just treat it like any other number.
थोड़ा बहुत तो इग्नोर मारना है, कुछ नहीं होता, इसलिए हरकत है।
Okay, now additionally in the same graph, we'll also understand one thing, that at the point B, for example, if we draw the tangent, it will have a slope of 0, because the function just about changes its behavior from increasing to decreasing across B. So here the slope will be equal to 0. Again, at the point C, if we draw a tangent exactly at that point, it will be a horizontal line, so its slope will again be 0, because the behavior of function is changing from decreasing to increasing. So additionally, we can also see that dy by dx is equal to 0 at precisely 2 points, x equal to B and x equal to C. Okay, so let's look at this with an example. So we'll start with rather simple example. We have y is equal to, let's say, 6x minus x squared. Okay, so we have to find the interval in x for which y increases with respect to x, y decreases with respect to x. So now we have a simple method for doing this kind of situation. We know that for any function y equal to fx and derivative dy by dx equal to f prime x, if f prime x is positive for a certain interval, then it means that fx is increasing for that same interval. Now, on the other hand, if f prime x is negative for a certain interval, then it simply means that fx is decreasing for that interval. So that we will just put into practice, okay, over here for this particular question now. So we'll replace the function with the given function. We'll replace fx with the given function, which is that quadratic function of 6x minus x squared. So let's apply these steps over here. For the function 6x minus x squared. So therefore the derivative of the function is differentiation of 6x minus x squared, which is 6 minus 2x. So now we can see that therefore f prime x or dy by dx is greater than 0 implies that 6 minus 2x should be greater than 0, implies that x should be less than 3. So this tells us that the derivative is greater than 0 for this interval, x is less than 3. Or we can say x belongs to the interval minus infinity to 3. So therefore we can say that y is increasing with respect to x for x belonging to this interval minus infinity to 3. So similarly, now you can find out the interval in which y is decreasing with respect to x. Okay. dy by dx is less than 0 implies that 6 minus 2x is less than 0, implies that x should be greater than 3, or x belongs to the interval 3 to infinity. So therefore that now tells us that y is decreasing with respect to x for the interval x being greater than 3 or going from 3 to infinity. So that means whatever the graph of the function, it should be something like this. It should be first increasing and then decreasing. And the point where it reaches this maximum value on the x-axis, the point x equal to 3. You can see for any value less than 3, the function is increasing. Any value after 3, the function is decreasing. And of course, at x equal to 3, the slope of the tangent is 0. Just make a note of this, people. We'll discuss more.
So the end point for us is minus infinity and plus infinity,
Yes.
not a fixed point like any number or else.
No, because see, this is a quadratic function, so y is defined for all real values of x, right?
Okay.
So what we say in maths language is the natural domain of the function is minus to plus infinity. There's no restriction on the value of x, right?
Okay, sir, understood.
Okay.
Done so.
Okay, so understood this question now?
Yes, sir.
Okay, let's try out another example. This time we'll take a slightly more interesting type of function. So we'll take a cubic function this time. Y is equal to x cube minus 3x. Okay. Now we want to find the intervals for which y increases or decreases. Just try this out yourself. We'll discuss in a moment. So apply the same technique like we've done in the previous question.
Done, sir.
Yeah, so can you tell me the answers for this? You can just send them in the text message.
Yes, sir.
Okay, so what makes this type of a question a little bit more complicated to solve is actually the solving of the inequality. After finding dy by dx, solving the inequality that the value of dy by dx is greater than 0 or less than 0. Let's see how that will be solved here. So first step, given that the function is this, we have derivative of the function or dy by dx as 3x square minus 3. So we can factorize that also and write it like this, that it is 3 into x minus 1 into x plus 1. So now therefore we know that derivative is positive will imply that 3x square minus 3 is greater than 0. So it will imply that 3 into x minus 1 into x plus 1 is greater than 0. Now you can see that we have the product of two things here, x minus 1 and x plus 1. In fact, 3 is also there, but 3 is a positive number. So the product of these two numbers, x minus 1 and x plus 1, will be positive when both of them are positive or when both of them are negative. So can you tell me for what values of x both of these are positive? X minus 1 is also positive and x plus 1 is also positive.
Sir, x
For what?
greater than 1.
Correct, x greater than 1, right? And on the other hand, both of them could be negative for
Sir,
what type of value?
smaller than -1.
Less than -1. You know? So this will solve So this will give us that result, that x is greater than 1 or x is less than -1. So we'll say that dy by dx, okay, is greater than 0 for x belonging to the interval less than -1 is minus infinity to -1. Okay. Union with the interval greater than 1. So that is 1 to infinity. Now, sometimes a good way of solving this inequality is by using something called the number line method. So to solve this inequality, we can use the number line, or it's also called Wavy curve method. Have you heard of this method in maths yet?
No, sir.
So I think you will be learning about this very soon in your basic maths track. Okay. So Wavy curve method is like this, that see, now we will compare these two things that we are multiplying, x minus 1 and x plus 1. So if you look at x minus 1, for it, the critical point on the number line is 1. At 1, it is becoming 0. Okay. But before 1, its value is negative. And after 1, its value is positive. So we just represent it like this. Okay. Next, let's look at the other quantity we are multiplying, which is x plus 1. Now for x plus 1, the critical point is what? It is -1. Okay. So let's say -1 is here. So this value now, x plus 1 is negative for any x less than 1, or rather less than -1, and positive for any x greater than +1. So for us, now the product of these two things, the critical points become -1 and 1, because now we can see that the product of these two things, x plus 1 into x minus 1, it will have a positive value here, a negative value here, and again a positive value. So this is just an easy way to gauge this concept that we've seen over here. So, okay, so therefore we can see that y increases for x belonging to this domain. This part, less than -1 and greater than +1. Whereas again, we'll see that dy by dx less than 0 implies that x minus 1 into x plus 1 be less than 0. So 3 is a positive number, so we can take it out of the analysis. So this is now implying that x belongs to the interval -1 to +1. Okay. So now we can see that y decreases for the same interval. And of course, dy by dx is 0 for exactly x equal to -1 and +1. So that means the graph of the function would be something like this. It would be increasing, then decreasing, then again increasing. Okay. And on the number line, this point would be x equal to -1. This point would be x equal to +1. So for any value less than -1, you can see it's increasing. Then between -1 and 1, it's decreasing. And then again after 1, it's increasing. So this is the information that we can get additionally about any given function. Not only we can calculate the derivative in general and the value of slope of tangent at a point, but by examining the intervals of x in which the slope is positive or negative, we can also understand the behavior of the function, that in which part of the domain or for what interval of x the function has a behavior such that it's rising or increasing, and similarly which part it is decreasing. Perv, which part exactly you're asking about? X greater than -1?
Sure, the first part.
No, see, when x is greater than -1, no? So for example, let's take a value of x greater than -1. Like let's take a value like x equal to 0. Okay, 0 is greater than -1. Now at 0, what is the value of the derivative? See, it is -3. It's negative, no?
Yes, sir.
So, but if you take a value of x greater than 1, like let's take a value of x like 2. Now you can see that this is becoming 3 into 4 minus 3. So that's 12 minus 3. So that's plus 9. But at a value like, let's say 0 or minus 0.5 or even plus 0.5, that is any value between -1 and 1, you will see that the product of these two things becomes a negative quantity. Because between -1 and 1, what is happening? The quantity x plus 1, okay, is a positive quantity, but the quantity x minus 1 is a negative quantity. So their product will become negative. Clear, Par?
Yes, sir.
Whereas if you take a quantity less than -1, then both of them are negative. Like take a value like -2 or -3 or anything like this. You'll see that x minus 1 is also negative, x plus 1 is also negative. So their product is positive. Similarly, take a point greater than 1, and you'll see again both of these brackets, x minus 1 and x plus 1, are positive. So obviously the product is also becoming positive. So that is how we solve an inequality like this. This type of an equation, as you know, is called an inequality. If I write something is greater than 0 or less than 0, the sign in between the left hand side and the right hand side is not an equality sign. So it's not an equation. Equation means we're equating two things. Okay. But if we write instead that left hand side is greater than or less than the right hand side, then we are expressing an inequality. They are not equal. So that in mathematics or algebra, these type of equations are called inequality equations. And whenever we have factorized terms on the left hand side, which we are expressing with an inequality with respect to 0, then this number line method becomes a very easy way of solving it. Or wavy curve method also this is called. Okay, so hope this question is clear to all of you. Okay, now let's move on to some discussions from worksheet number 4. Hope all of you are now done with worksheet 1, 2, and 3 completely. Each and every question with answers and everything. If there's any doubt in worksheet 1 or 2 or 3 pending, please let me know immediately, because those will be the most important worksheets with respect to your upcoming test on Sunday. Yes.
Sir, guys, scroll up it for a second.
Yeah, sure. So before we come to worksheet 4, just make a run through worksheet number 1, 2, and 3. And in case there's any doubt, just let me know.
So worksheet number 3, fifth question.
Okay.
Okay, sir.
Okay. Right. So let's start with, before this, let's start with worksheet number 3, question 5. If I remember correctly, that is a rate measurement type of question. Just a moment. Yeah, so let's go over the question again. So it says that gas is pumped into a cylinder which is initially empty. Okay, so one important information given here is that the cylinder is initially empty. So mass is 0. Mass of gas is 0 at time t equal to 0. That's how we can interpret this. Okay. Now what is happening is gas is being pumped in, okay, through an inlet, let's say, okay, at the rate of 4 plus t grams per second. So that's a mass rate. So this this is given as the rate of pumping gas. It's an instantaneous rate. It's variable with respect to time. But at any time t, it is so many grams per second. So at t equal to 0, for example, is 4 grams per second. But by the time the time is 1 second or 2 seconds, it is accordingly increased to 5 or 6 grams per second, like that. Okay. But right from the start at t equal to 0, there is also a leakage which is at 2 grams per second. So there is a rate of leakage, and that is equal to 2 grams per second. So from this, now we have to find the net rate at which gas leaks out from the tank, or gas increases in the tank as a function of time, that net rate. And from that, we have to find out the rate as a function of time and all that. Okay. So let's come to that. So let's visualize this like this, that suppose we have some kind of a tank like this. Okay. Now initially at t equal to 0 time, the mass of gas in the tank is 0. So to denote that it is initial, we can even, for example, write this as m0. But there is an inlet through which gas is coming in. And also somewhere, let's say there is a small leakage. Gas is also leaking out. So we can see that rate of pumping in gas, that is equal to 4 plus t grams per second. The rate of leakage is equal to 2 grams per second. So this is all the information that is given to us. These three pieces of information that are given to us. So from this, we can see that at some point of time t, let's say there's a certain amount of gas in the cylinder. So at some time t equal to t, let's say the mass of gas in the cylinder is m. So the instantaneous rate of change of mass, that will be equal to the rate of pumping with a positive sign, because it's increasing the mass of gas, minus the rate of leakage. So rate of leakage comes with a negative sign, because what the leakage is doing is it's reducing the mass of gas inside the tank. So that's why the net rate of change, okay, this is the net rate of change of the mass of gas. So that is equal to 4 plus t minus 2, or 2 plus t grams per second. That is the net rate at which the mass of gas is increasing with respect to time. So it's an instantaneous rate, as you can see. So it's changing from instant to instant. This part is clear. This was the A part of the question, right? This is clear, I hope.
Yes, sir.
Okay. Now, next thing is, from this we have to understand what is mass as a function of time. Mass is some kind of function of time. So what type of function that is? Okay. So for this, again, we have to use that kind of logic, that we can see that the derivative of the function dm by dt, or f prime, that is 2 plus t. Now notice, this is what type of function? The derivative is a linear function, or it is a polynomial of first degree. So therefore, what we can say, that the function itself, it should be what type of function? It should be a quadratic function of time, because derivative of quadratic is linear, no? Is this clear?
Yes, sir.
Okay. So now we do this question in the same method like we've done one question before. Okay. So I'll assume that the mass, which is this function of time, is some coefficient into t square plus some coefficient into t plus c, where A, B, C, they are unknown constants. So now we have to somehow solve for ABC. So to solve for ABC, I need three pieces of information. Now let's see what information is known to me. The first thing that is known to me is that the value of m at t equal to 0 is 0. Okay. So substitute that in the above equation. So 0 should be equal to a into 0 square plus b into 0 plus c. So that is telling me the constant c is 0. That is the first piece of information. Okay. The second piece of information that is known to me is that dm by dt is equal to how much? It is t plus 2. Now we have just worked this out above. See that just above we had written. So this is telling me that rate of change of the quantity AT square plus BT. So C already I've shown to be 0 above. This should be equal to how much? This should be T plus 2. So this will give me some values for A and B. Understood now? So when we solve this, differentiation of AT square plus BT is how much? It is 2A into T plus B. So if we compare the left hand side and right hand side, you can see that 2A constant should be equal to 1, which means A should have a value of half or 0.5 and B's value should be 2. Okay. So now correlating this information, we can see that m as a function of time is 0.5 t square plus 2t. Now you can see this function of time will satisfy all the conditions that we've earlier got, which is that m is 0 at t equal to 0 and that dm by dt should be equal to t plus 2. So this equation is going to satisfy this. Okay. So that means it's the correct equation to represent m as a function of time. Okay, so this is the B part. And C part, you have to just take some values of this and plot a graph. So you will see that that graph has a behavior such that it increases with respect to time in what is called a parabolic curve, because it's a quadratic function. So the curve or the graph of a quadratic function is called a parabola. So we plot m as a function of time. So I'm just showing you the arbitrary plot, but you can actually take some values and plot this. So it will be something like this. So for example, at 1 second, you can see it is becoming 0.5 plus 2. So it is 2.5 grams. But for example, by the time you move to 2 seconds, it's becoming 4 into 0.5. So that's 2 plus 2 into 2. So that's 4. So it's becoming 6. Now, by the time we move to 2 seconds, becoming 6 grams. And so on and so forth. Okay, so just make a note of this if required. Okay, then let's move on to so I think we'll move on to worksheet number 4 now after this.
Just a second.
Yeah. Also, I have one more question from before. Shan, you have asked me that what is the derivative of x raised power e?
Yes, sir.
Okay. So this is going to be like if y is equal to x to the power e. Here e is a number, no? It is a real number, okay, which is approximately 2.7 like this. So basically this is of the type x to the power n, where that n is equal to e. So dy by dx will become n into x to the power n minus 1. So this will be the derivative. Understood now?
Yes, sir.
Now more this thing question is like, suppose we have y is equal to 2 raised power x, or some other number other than e raised power x, then how do we find dy by dx? So there's no direct formula for this. So what we do is we take log on both sides. So we say that ln y is equal to x times ln 2. Right, this is making sense? It will be ln of 2 raised power x, so that will be, so let's do it in two steps. Yes.
Sir, can you send only the answers for assignment number 3 so that we can just confirm with our answers?
Sorry, come again. Can we?
Sir, can you send the answers for assignment 3?
Yeah, I've sent that already now in the group. Can resend it, but you're talking about assignment 3 or assignment 4?
Sir, only the answers for assignment 3.
Yeah, I've sent that before, but I'll resend it, but it's already there on the group. Worksheet 3 answers. I'm just going through the group, just a moment. Okay. Yeah, see, it is sent something on 18th or so. I'm just resending it. Okay, so I've resent it on the group, but it sent it earlier also.
Okay, sir. Thank you, sir.
Got it now? Okay. Yeah, so coming back to this, that now I'm just giving this as an example for you here. This type of differentiation is not immediately important for us in physics. Okay, differentiation of 2 raised power x. But if we have to do that, then we have to express it this way, that ln y is equal to ln of 2 to the power x. Then using the property of log, any power comes outside, so it is x ln 2. Okay, so now what we do is we differentiate both sides. So differentiation of ln y with respect to x will become differentiation of x into ln 2. Now chain rule. So this can be d by dx of ln y can be treated as differentiation with respect to y of ln y into dy by dx. And on the right hand side, ln 2 is a constant, so it will come out. So that into differentiation of x. So differentiation of ln y with respect to y will become 1 by y. And on the right hand side, differentiation of x is 1. So as you can see, dy by dx is going to become y times ln 2. ln 2 is just a constant. And y was what? 2 raised power x. So dy by dx will become 2 raised power x times ln 2. So you don't need to know this kind of differentiation for your physics applications in basic calculus yet. But since you asked for the differentiation of the other one, x raised power e, so I just give you an example of, so x raised power e is simple. It's like this differentiation. But if you had something like this instead, any real number other than e to the power x, how we differentiate it, it would be differentiated by this kind of method. Okay, let's come to worksheet 4 next. So just give me a moment, I'll share the worksheet and we'll go through it step by step.
Sir,
Yes.
if any equation is like n to the power of x, then how will we differentiate that type of equation?
Yeah. So that's what I've explained over here. Like instead of 2, na, you can have any number n. So if you have y is equal to any number n to the power x, we'll just apply the same steps, that ln y is equal to x ln n, and proceed in this manner, and just replace 2 with n, and you'll get the same answer. So dy by dx will become n to the power x into natural log of n for this particular function. Understood, no?
Okay. Yes.
So for example, in advanced calculus, when you do in maths, this will be an additional formula for you, that differentiation of n to the power x is n to the power x ln 2. But there is a logic behind that formula, and the logic behind this formula is this. Yes, e raised power x's derivative is e raised power x. That's true, Caleb. E raised power x is a unique function which has that property, that derivative of e raised power x is equal to e raised power x. Okay, but that doesn't apply to any general numbers power being x. Now, that formula will not apply to 2 to the power x or 5 to the power x. It applies only to e raised power x. You understanding the point now, Caleb?
Yes, sir.
So, Akshat, to answer your question, okay.
So yes, I got my answer actually.
Understood, no? So
Yes, sir.
instead of like 2 raised power x, if we have 2 raised power some function of x, then just chain rule we have to apply, no?
Okay.
Yes, Adinath, of course, ln e is equal to 1. That's true, because e is equal to e to the power 1, no? So if ln of some number x is equal to y, that means x is equal to e raised power y. So if you replace x with e, then obviously y is equal to 1, right?
Yes, sir.
Okay, so let me share worksheet number 4 now, and let's go through the questions. So any doubt in the first question, any of the parts? Some of them are a little bit complicated. They are all application of chain rule. Okay, fine. Let's do this one. Part D. So part D is like, we have to, like, you can say in a sense, just do a single substitution. The function ln is applied to the function sec x plus tan x. Okay, we'll do C also. So let me do this first. Okay. So we substitute sec x plus tan x as z. So y becomes a simple function. It just becomes ln of z. So once you've done this substitution, you can see that your chain rule step is very easy. This is this is differentiation of ln z multiplied by differentiation with respect to x of sec x plus tan x. Okay, so that is 1 by z into, now differentiation of sec x is by formula sec x tan x, and differentiation of tan x is sec square x. Now finally substitute z as sec x plus tan x. So this becomes sec x tan x plus sec square x divided by z, where z itself is sec x plus tan x. So now you can see that if you take sec x common in the numerator, then the term sec x plus tan x cancels out. So we are left with just sec x. So that's what the derivative is becoming. Dy by dx is equal to sec x plus tan, is rather equal to sec x. Right, we'll do the C part also. I hope this is clear. Okay, Parv, I'll come to those questions also. Okay, let's come to question 3, I mean C part of this. So this can be done very simply by using a property of log. Now we use this property that log to any base of e to the power n equals to n times log e. So use this property over here. So your function reduces to something simpler. Half is just a constant, so it is ln of some function. So now you use substitution.
So can you explain the third step?
Yeah. Just a moment. This step here to here.
Sir, the one which you have squared or highlighted.
This one.
Yes, sir.
Yeah, this is using the property of log, that log of e to the power any exponent n is nothing but n times log e. Understanding now?
Sir, understood.
So this is x square plus 2x raised power half. So that's the same thing as half of ln of x square plus 2x. Yeah, Caleb, you want me to explain about the exponential function or like?
No, question 1E.
Oh, sorry, sir. Yeah, I understood now. Yeah. Okay, so I'm clearing this now. Let's come to E part. So E part is like, you have to apply chain rule for each of these individual things. So differentiation of y with respect to x. When we take the differential operator inside, is going to be differentiation of this term ln 1 plus x, okay, plus separately differentiation of this term ln 1 minus x. Now, when I'm doing a differentiation like this, that, you know, differentiation of ln 1 plus x, or any function like this, I'll take 1 plus x as z, right? So we are doing differentiation with respect to x of ln z. So that will become differentiation with respect to z of ln z into dz by dx, that kind of thing. So it will become 1 by z into differentiation of 1 plus x. So that is 1 upon 1 plus x. Caleb, these steps are clear now?
Yes, sir.
So this is becoming 1 upon 1 plus x. Okay. But similarly, when I do this one here, what is going to happen? The z is 1 minus x now. So it is going to be differentiation of 1 minus x. So this ln terms differentiation is 1 by z. So that is 1 upon 1 minus x. But into differentiation of z itself, and z is what? 1 minus x. So differentiation of 1 minus x is how much? Minus 1. Okay, clear about this point, Caleb?
Okay.
In the chain rule step, now here, this term, here dz by dx was just 1. So it was 1 upon z into 1. But here it is becoming like 1 by z into minus 1, because this is 1 minus x now. So this is becoming 1 upon 1 plus x plus 1 upon x minus 1. I can write it like this, taking the minus sign outside.
Yeah.
Or I can write it like this also instead. You can also write it like this, minus 1 upon 1 minus x. Okay. And the next step I can write it as like this. Okay. And now take LCM in the denominator. So x square minus 1, and the numerator becomes what? X minus 1 plus 1 minus x. So that is 2x. So this becomes the answer.
Okay, sir.
Understood? Now, so separately chain rule for differentiating this term, separately chain rule for differentiating this term. So that's how we come to this step. Okay, this one is this, and this one's differentiation is this. And then just algebra. Okay, any other part required in first question? Okay. Let's come to the second question then. Let's understand this. So we have a thin sheet of ice in the form of a circle. Now the ice is melting in such a way that the area of the sheet is decreasing at the rate of this much. So what is the rate at which radius is decreasing? At an instant when the area is so much. Okay. So again here, what is happening is area is a function of radius. Okay. And area is decreasing with respect to time. This is a quantity which is known to us. And from that, we have to find the rate at which the radius is changing. So we have to use chain rule. Okay. That is differentiation of area with respect to time is differentiation of or rate of change of area with respect to radius into dr by dt. The only difference is here, this is given to us and this is asked. Okay, but so this logic is clear. Still have to see how to implement it, but the meaning of the question is clear now.
Yes.
So now we can approach this in two ways. Okay, since the unknown quantity is the rate of change of radius, so we can also invert this. So since, let's say, surface area we are taking with the symbol A, and radius of the disk we are taking with the symbol R. So A is equal to pi r square. So we can also invert this as a function that R is equal to square root of A by pi. So we can also express it this way. Okay. So one method is that we can go with this. That we start with this formula only. So dA by dt is equal to differentiation of pi r square with respect to time. So that is dA by dr into dr by dt. So that gives us the relationship between rate of change of area dA by dt and rate of change of radius, which is 2 pi r, gives us this relation. Now we have to now see what is given. That given that at a certain instant E is equal to 12, what is it, meters square. Okay, and the rate at which the area is changing, okay, so it is melting, so it's decreasing at the rate of this much. So we'll write it with a minus sign, meter square per second. So we have to find dr by dt. So we have to use this formula. Okay, so now what we'll see is that at the instant when area is this much, how much is the radius? So pi into r square is 12. So r is equal to square root of 12 by pi meters at that instant. Yes or no? At the instant when pi r square is 12, so r's instantaneous value is this much. So from this now you can see that in this equation, dA by dt is equal to 2 pi r into dr by dt. So I'll substitute dA by dt as this, minus 0.5 meter square per second, okay, into 2 pi, sorry, that is equal to 2 pi r. So that is 2 pi into square root of 12 by pi in meters, okay, into dr by dt. So my unknown quantity is what, dr by dt, and I'll get that dr by dt from this one. Okay, so dr by dt finally will become what? Minus of, now you can write this as half and take all these terms this side. So 1 upon 4 square root of 12 pi. Or you can write this as minus of 1 upon 8 square root of 3 pi. And this will be in what unit? It will be in meter per second. And the minus sign is showing you that the radius is decreasing with respect to time. Okay, per beta, this is clear. The calculation part also.
I didn't get the last step.
The last step, the value of dr by dt.
Yes, sir, that minus 154 to 12 by.
हाँ, ये कैसे है ना, देखो इस ये वाले स्टेप को मैंने थोड़ा डिटेल में सॉल्व किया है. Okay, so see, in this step we can also write this as, the left hand side can be written as minus 0.5, can be written as minus half. Okay, and on the right hand side, this thing that we have not, 12 pi into 12 by pi ka square root, this can be written as 2 times square root of 2 pi. Correct?
Yes, sir.
Understood, no? And then just cross multiply. Okay. And then express 12 pi as okay, so that's how we get to this last step. So that part is just algebra, but rest is like this. This is clear enough for now?
Yes, sir. Got it.
Okay. Okay, now second method, we can also, do it somewhat more easily, because see what is happening. Area is given to us and dA by dt is given to us. And what we have to find is dr by dt. So from the beginning, we'll see that it's more convenient if we can express r as a function of a. Then we can say that, okay, dr by dt is equal to dr by dA into dA by dt. So this is the reverse way of solving this. Okay. So in this approach, area is equal to pi r square. That means r as a function of area is how much? It is square root of a by pi, which is basically just a constant 1 by root pi multiplied by a to the power half. Right. So therefore, from this we can see that dr by dt is dr by dA into dA by dt. So that is differentiation of this function, a to the power half into dA by dt. So root pi is a constant, so that just comes outside. Okay, into anything to the power half is 1 by 2, okay, into dA by dt. So that is basically 1 upon 2 root pi and now we can directly substitute the values. So sorry, not this. This is our dA by dt. And this is our E's value at that time. So from here we can see that dr by dt is 1 upon 2 root pi into 1 upon root of area. So that's 12, okay, into dA by dt, which itself was minus half. You can see this will become minus 1 by 8 root pi meters per second. So this is a more efficient way of doing the question. So Parv, hope this is also clear.
Yes, sir.
Sir,
Yes.
sir, could you please scroll up to question 1 for once?
Question 1, which part, beta?
Sir, I was writing the last part.
Okay, I'll just go back. Okay, just a moment. So, Parv, this is clear. I can rub this now.
Yes, sir.
Okay. So going back to question 1, yeah, Srijita, which part, beta?
No, sir, I'll write it on my own then.
Sorry, you'll.
Sir, I will write it on my own.
Okay. No, but this is now removed actually, no, from the board.
Yes,
The
sir.
part is stuff.
Sir, I have understood.
Okay, okay, okay. Just a moment, people. I'll join you. Huh? Okay, yes, Caleb, we'll discuss question number 3. Now see, question number 3, we did not have to do any calculation. Okay. We just had to find this thing that, like, this is, let's say, no, the diagram is not made very well. So this is a person who's moving towards this at a certain speed. Okay. Now this is his shadow. Okay. So this is the tip of the shadow. So we have to find out whether the tip of the shadow is moving towards the person or away from the person. And we have to find whether the tip of the shadow is moving towards the wall or away from the wall. But now we will actually convert this into a numerical problem. We will even find the rate at which, or the speed of the tip of the shadow. We can even do that. Okay. So you can add one part to the question. So the question is clear, na, Caleb, what's happening? This is a fixed wall. Right, on which there is a lamp which is throwing light like this. Okay, so I'll just switch to my whiteboard. The wall. Now let's say somewhere here is the lamp. So as you know that the lamp will be throwing light equally in all directions, but if we trace a beam of light that just about skims his top, then light on this side of it is blocked. But again, light here just about reaches the floor. So all the light before this reaches the floor, and all the light after this reaches the floor. So this is now a dark region where no light reaches because it's getting blocked by him. So this is his shadow. So if we take the tip of the person, I mean, if we, let's say, label the height of the person as AB, okay, this as C, and this as D and E. Okay. So we can see here that in a more proper diagram, now I'm representing him also with a straight line, or rather his height with a straight line. Okay. Okay, so in this diagram, you can see now that this is 90 degrees, this is 90 degrees. Okay, this was, I think, 5 feet, right? And this was 2 feet. Now, this is a variable distance. So I'll take it as, let's say, x1, because this is moving. This guy is moving at a rate v. So this also becomes a variable distance. So let's take this as x2. So first thing we can understand that x1 is changing in such a way that its rate of change is minus v. Okay, so x1 is basically the distance TA in my diagram. So that is person to wall, right? And x2 is the distance AC. So that is the tip of the shadow to the person. Okay, so this is what is the tip of the shadow. So Caleb, so far it is clear.
Yes, sir.
Okay. So now again you can see that there is a relationship between x1 and x2, which we can get from geometry. Can you tell me what is the most convenient way of getting the relationship of x1 and x2?
The similarity.
Very good.
BPT.
Yes, very good. So now we can see that triangle DEC and triangle ABC are similar. So we can say base upon perpendicular is equal to base upon perpendicular. So x1 by 5 is equal to x2 into 1 by 2 minus 1 by 5, which is 3 by 10 times x2. So from this we have the, now x1 is a known quantity, x2 is a known quantity. So we have the relationship that x2 will become 2 by 3 of x1. So as far as this question was concerned, we can just understand logically that after some time, if this guy moves to this position, to A prime, B prime, okay, then the tip of the shadow would have now moved to this point, C prime. So you can see that the distance x2 is also decreasing. So the tip of the shadow is moving towards the person. And of course, C prime is closer to the wall than C is. Okay, so from this diagram itself, we can understand that therefore the tip moves towards the person, not away from him. Okay, tip of the shadow. And also obviously the tip of the shadow moves towards the wall. But now from this, we can even find the relationship between the two. So dx2 by dt is equal to 2 by 3 of dx1 by dt. So that is minus 2 by 3 of d1. Okay. So therefore, you can see that the length of the shadow, that is only our x2, no? That is decreasing at the rate of 2v1 by 3 or 2v by 3. Where this v was how much? It was 0.5 meters per second. That is,
Yes.
yeah. So 1 by 3 or 0.33 meters per second. So the length of the shadow is decreasing at this rate. And now also you can see that the distance of the shadow from the wall, I mean the distance of the tip of the shadow from the wall, if I write that as S. Okay. And also you can notice that S is equal to x1 plus x2. Where S is the distance of the tip of the shadow from the wall. Okay. So from this I can see that ds by dt will become d by dt of x1 plus x2. Okay. So that is going to be dx1 by dt plus dx2 by dt. Now from above we can see that dx1 by dt was minus v and this was minus 2 by 3v. So this is minus of 5 by 3v. So this is showing you that the distance between the tip of the shadow and the wall, that is decreasing at the rate. So S is decreasing at the rate of 5v by 3, or that is 2.5 by 3. So that is 0.83 meters per second. Okay. So this is like the additional information that we can get. But as far as this question was concerned, now you did not even have to use differentiation. You just had to use the, understand the geometrical relation of how these two triangles are changing as as the person is walking towards the wall. Both the larger triangle and the smaller triangle are changing in such a way that their bases are decreasing with respect to time. So the smaller triangle's base is nothing but the distance between the tip of the shadow and the person. And the larger triangle's base is nothing but the distance between the tip of the shadow and the wall. So both those triangles are shrinking in size such that their heights are remaining constant, but their bases are decreasing. So accordingly, the answer for the A and B part. Okay. So Caleb, this is clear, I hope.
Yes, sir.
So you can
Sir,
sort of add this part to the question, that find the rate at which the shadow length is decreasing. So that is this part, 0.33 meters per second, and find the speed at which the tip of the shadow, that is this point C, is moving towards the wall, and that is the second part that I've worked out here, that is 5 by 3b, or that was 0.83. Yes, somebody had some doubt?
sir, so this is not an sum of increasing or decreasing function.
No, this is just like at the given instant, if one thing's rate of change is known. So what thing's rate of change is known? X1's rate of change. Then what we can say about the rate of change of X2 or the rate of change of X1 plus X2, whether it is positive or negative.
Oh.
So dx by dt is equals to minus v. We have assumed it, right?
No, that is C. X1 kya hai beta yahan pe? X1 is the distance between the points D and A, no?
Yes, sir.
Okay, now you can see in the diagram it's given to us now that the person is walking towards the wall. So isn't X1 decreasing?
Yes, sir.
So hence the minus sign, and at what rate it is decreasing? At whatever speed he is walking.
Okay.
So that's why. Okay, so I hope this is clear fully. Let's come back to the worksheet. So we'll discuss. This was question number 3. So let's move on to 4. Yeah. So 4 is the type of question we had discussed once in class also before, but only thing is here the values are a little bit tricky. So this is going down at the rate of 15 feet per second. Okay. Now since this is going down, so its distance from here is a variable quantity, whereas this is a stationary point. The person is at rest. So since this is stationary, this distance, the base of this triangle will be a fixed quantity. So capital D, which is given to us as 500 feet, this is a constant. Okay. But X, which is given to us as 200 feet, this is the instantaneous value of X. So as you can see, X is changing at the rate of minus V again. Why minus? Because X is decreasing. one important. Okay. Now coming to theta, that is this angle. So you can see that tan theta is equal to x by d. So from this now, what we have to find is about the rate at which the angle of elevation is changing with respect to time. So we want to find out d theta by dt. So we'll just use chain rule. Okay. So rate of change of left hand side of this equation, which is tan theta, should be equal to rate of change of right hand side. So you can see x is an instantaneous quantity. X is a variable or an instantaneous quantity. So that makes theta is also a variable. Okay, whereas d is a constant. So this has to be kept in mind while differentiating. So now use chain rule. So differentiation with respect to time, we can also write as d by d theta, or differentiation with respect to theta into d theta by dt is equal to, now on this side d is a constant, so directly this. So by formula we know this is sec square theta is 1 by d into dx by dt. So inverting this formula now, we will get d theta by dt as the unknown quantity will become 1. When I take 1 upon sec square theta on that side, it will become cos square theta divided by d into dx by dt. So this is the formula that I'll get. Now in the formula, I have to substitute the value of d, which is directly 500 feet. I have to substitute the value of cos theta. So I'm coming to that. For that, you have to look at this triangle. And dx by dt will be substituted with how much? Minus v, or that is minus 15 feet per second. Okay. So just if you're writing this down, just note down up to this step. Then we will see the substitution of these values. Okay, so now let's see about the substitution part. Okay. So let's make some place here. So see, this is a fixed value 500 feet. Okay, but at the given instant, x's instantaneous value is 200. Okay, so if I take this as s, the hypotenuse. Okay, so when x is equal to 200 feet, you will see s will become 100 root 29 feet at that moment. Okay. So S's instantaneous value will be 100 root 29. So cos theta is basically d by s. So at that instant, at the instant when x's value is 200 feet, cos theta's value will become 5 by root 29. So remember, theta here is also instantaneous. So it's only at that moment, it's not constant. Okay. So this we will substitute in this. So we'll get d theta by dt's value as 25 by 29, that will be cos square theta, divided by d, which is 500 feet, into dx by dt, which is minus 15 feet per second. So the unit you can see, feet per second divided by feet, will be in per second. So that is actually radian per second, because 1 radian is just a unit. It's a dimensionless unit. So we'll get d theta by dt. On solving this, 25 by 29 into 15, that will give us a value of 3 by 116, but with a minus sign. But the unit of this will become radian per second, because you can see from here the unit is second inverse. And as far as an angle is concerned, second inverse is the same thing as, or if we express the angle just as a number, then it's in radians, because angle is defined as arc upon radius in radians. So theta in radians is just the ratio of arc upon radius. So for example, 1 radian is just unity, because it's 1 meter divided by 1 meter, 1 centimeter divided by 1 centimeter. Okay. So d theta by dt in per second is the same thing as in radians per second. So that is why the natural unit that we'll get over here for this value of d theta by dt is 3 by 100 and is in radians per second. So from the sign being negative, we can say that theta is decreasing at the rate of 3 upon 116 radians per second. Okay, so hope this question is clear. 2 or 3 people have asked this, so hope all of you have understood not only the differentiation part, but how we substituted cos theta by using the geometry of the triangle. Okay, so we will hope this is clear. Okay. Now let's pick up some examples from the last question. So here we have to find out the intervals in X for which the function is decreasing or increasing. Or in other words, the intervals of X for which the slope is positive or negative. So basically we have to find out, so we have to apply that concept in these questions, that if for a given function, what we learned, if dy by dx is greater than 0, it means that the function is increasing. And if dy by dx is less than 0, it means that the function is decreasing in that interval. Okay. So let's see if you have any doubts in any of the parts here. Okay, part C, let's start with that. So part A and B, in case you haven't attempted before, they're just like the two questions we did in class today. One was a cubic function, one was a quadratic function. So just apply that same type of method, but just we had taken 6x minus x cube, I think, or we had taken, sorry, 6x minus x square. Here it is 2x square. So the values will be slightly different, okay, even for the cubic one, but the method is exactly the same. So now applying the same principle over here for this part C, let's solve it. Sorry, 1 by x, not x square. So this is the function. So the derivative of the function is 1 minus 1 by x square. Comes by differentiating this. Okay. So now dy by dx is greater than 0, means 1 minus 1 by x square is greater than 0. So here we need not, solve it and factorize. We can do it in a more simple manner, that 1 is greater than 1 by x square, which means that x square should be greater than 1. Now x square is greater than 1, we understand what that means, that x is greater than 1 or x is less than minus 1. So from that we understand that y is increasing with respect to x for x belonging to the interval minus infinity to minus 1 union with 1 to infinity. So this is the first part where the function is increasing. So these are the two intervals in which the function is increasing. Okay, now to talk about the interval where the function is decreasing. Now, before we come to that, one important thing you have to understand about this function is that here x belongs to the interval minus infinity to 0 union with 0 to infinity. Or we can say x belongs to all real numbers except 0. So x should not be equal to 0 because y is undefined for x equal to 0. So whatever interval we express for increasing or decreasing, it should not include the point 0. It should be excluding the point 0 because 1 by 0 is an illegal operation. It's undefined. So for this function, y is defined as a real number only for all negative values of x and all positive values of x. It is not defined for x equal to 0. So as you can see in this part, we have not included 0 at all. It's less than minus 1 or greater than 1. Okay. Now, similarly, when we come to the second part, where we are looking at y is decreasing with respect to x. So dy by dx should be less than 0. So dy by dx was 1 minus 1 by x square. So this quantity should be less than 0. That means 1 should be less than 1 by x square, or x square should be less than 1. But remember, x cannot take the value of 0 in this function. Okay. So this will actually be x between 0 and 1 union with x between minus 1 and, or x belongs to the interval minus 1 to 0 union with 0 to 1. This is the interval in which the function is decreasing. So we cannot write that interval as minus 1 to 1 because it's excluding the point 0. Why? Because this function itself cannot take the value of x equal to 0. So in this function, x should not be equal to 0. Can be any other real number, negative or positive. So that becomes an important concept over here. Yeah, so Pratham, to answer your question and in general to clarify, in Sunday's test, this concept of sixth question that will not be tested. The behavior of a function, whether it is increasing or decreasing, that thing will not be tested on Sunday's test. You'll have questions up to application of chain rule and simple questions on rate of change, like the area and volume type of questions. Again, the type of question we did today with the lamppost and the person moving and all that, those type of questions will not be coming in this major test 1. That will come in the next major test after that. Basically, you have to pay maximum attention to all the methods of differentiation, including chain rule, product rule, quotient rule, all those things, and simple examples of differentiation used as a rate measurement, like rate of change of area, rate of change of volume, etc. Or the type of questions I've given you in worksheet 1, 2, and 3 also. From worksheet 4, you can just do question number 1, that chain rule application. Okay. Now this next set of questions are a little bit more complex. Okay, so like I'll explain 1 or 2 of them today. Okay, but it will take us a little bit more analysis and a little bit more practice to understand questions like this. So let's start with this one. Sine square x minus sine x. Okay, let's think of how we'll find the interval within 0 to 2 pi in which the function is increasing or decreasing. So I'm just switching to my whiteboard now. So we can see that first step, the differentiation of the function is differentiation of sine square x minus sine x. So that is differentiation of sine square x minus differentiation of sine x. So this one will be by chain rule. Sine square, so the differentiation of something squared is 2 times of that. It's like z square. So differentiation of z square is 2z into dz by dx. So z is sine x. So dz by dx is cos x. So you can write this as cos x into 2 sine x minus 1. Okay. So this is my derivative. Now to find out when the derivative is positive and when the derivative is negative is a little bit more complicated. So we'll again have to use that number line kind of method, but the variables in the number line are not related to x, they are related to cos x and sin x within the interval 0 to 2 pi. This is where we'll understand now that therefore y is increasing for dy by dx being positive. So that implies that cos x into 2 sin x minus 1 should be positive. Okay. Now let us look at each of these things individually. Okay. Cos x, if you look at the graph of cos x on its own, with respect to x from 0 to pi, or rather 0 to 2 pi, it's like this. Okay. So you can see that cos x is greater than 0 for x belonging to 0 to pi by 2 union with 3 pi by 2 to 2 pi. And cos x is negative for x belonging to pi by 2 to 3 pi by 2. So we'll put this information on the number line also later. Okay. Now the second factor that we have is 2 sin x minus 1. So we can see that 2 sin x minus 1 is greater than 0, means that sin x should be greater than half. And 2 sin x minus 1 is less than 0, means that sin x should be less than half. So when this happens and when this happens, we'll understand that from the graph of sin x now. So if you look at the graph of sin x, so this is where your knowledge of trigonometry also becomes important in a question like this. Sin x graph is like this, let's say. But now we are not interested in just negative positive. We are interested in this term, greater than or less than half. So we have to understand where this half is occurring. So you can see that this is pi by 6 or 30 degrees. And this is 5 pi by 6 or 150 degrees. So we can see that this is occurring for x belonging to pi by 6 to 5 pi by 6. And this is everywhere else. So x belonging to 0 to pi by 6, so not including 0, because at 0 it's 0. Yeah, including that actually, because it's less than half now. 0 to pi by 6, right? Union with 5 pi by 6 to 2 pi. So I'm just going to minimize this for a moment. You go through what we've done till this point, and then we will finally solve for this inequality, that when this product is positive and when this product is negative. So you can also see that for this interval now, 2 sin x minus 1 is positive. And for this interval, 2 sin x minus 1 is negative. Okay, so now let's put together that information in terms of a number line. So in this, if you look at the Cos X factor, we saw the critical points for Cos X were like overall, let's say we are looking from 0 to 2 pi. So Cos X is positive in fourth quadrant. Just now we had seen that, and positive in first quadrant. But between pi by 2 and 3 pi by 2, it is negative. Now that term 2 sin x minus 1, that was a more complicated term. So if we go back here, you can see that this term had this kind of intervals. Pi by 6 to 5 pi by 6, it's positive. So pi by 6 or 30 degrees is somewhere here. And 5 pi by 6 or 150 degrees. So this one is positive only in this region. In this point and this point. Whereas everywhere else it is negative. So now we can see that this becomes a boundary point. Okay. This becomes a boundary point. So the product of these two terms now, cos x into 2 sin x minus 1, which is this point here. So this product is negative in this region. It's positive in this region. And again, it's negative in this region. Again, it's positive in this region. Again, it's negative. So you can see that therefore, y increases or dy by dx is positive for x belonging to this interval. This one here, pi by 6 to pi by 2. Okay, union with this one. 5 pi by 6 to 3 pi by 2. Whereas y is decreasing with respect to x, or dy by dx is negative, which means that this quantity here is negative. For x belonging to 0 to pi by 6, that's this one here. Okay. Actually, it includes the point 0. Union with this interval over here, that is pi by 2 to 5 pi by 6. And then finally, union with this third interval here, 3 pi by 2 to 2 pi. So these become my final answers. These are the intervals in which the function is increasing or decreasing. So as I told you, these last few questions are a little bit more complex, and we will do more practice and some more analysis related to these type of things. Okay. So that you will have more experience with solving these kind of questions. Okay. So for Sunday's test, make sure you first of all like revise the content of all the lectures, especially up to lecture number 5, that is up to the previous lecture. Make sure you go through all my lecture notes and all the examples that I've done in class, numerical examples. You can do them on pen and paper yourself again. So that itself will be a good practice. Okay. In addition, worksheet 1, 2, and 3, make sure each and every question you have revised and gone through. Also, the questions that I had given to you specifically from the module. Okay, a few questions from exercise 1, 2, and 3. So those questions, make sure you go through them. And in worksheet 4, you can revise through question 1 in particular. Question 1, all the parts. Okay, I've sent you the answer key with the hints, so you can verify also. So that will be more than sufficient for the test coming up on Sunday. And then after that on Monday, and you can revise this last part over here, so that next week when we have our lecture, we can continue from this point forward. Okay. So that's it for today's session, people. Wish you all the best. And I really think if you just do the revision properly, you have an opportunity of doing very well in the test coming up on Sunday. There will be like approximately half the questions in physics will be calculus and half will be from vectors. So make sure you're revising both of them with equal importance. All right. That's it. Wish you all the best. Thanks for attending, people.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Bye, sir. Thank you.
Okay. Bye, people.